Hi guys, my name is Angelo Rajadurai. I'm part of Oracle in the systems division. I'm an engineer who works in the ISV engineering organization. I've been with Oracle and Sun for the last 22 years, and I've seen this chip thing developing. What we're here to talk about today is not a tiny little change in the chip design. We are doing something completely different. We are doing something revolutionary. We are doing something very, very different that the industry is not even beginning to think about. We are not doing some evolutionary thing. It's a revolutionary stuff that we are doing. We're calling it software in silicon. What it is really pushing some software stuff into silicon. And because of that, what we're going to do is gain some huge performance gains, amazing performance gains. We are also going to do some great security gains. We are making this whole thing more secure because we're pushing software in silicon. And again, if you look at it, people are talking about big data. People are talking about data growing. What we're doing by moving software into silicon is we're going to talk about how we're going to use this to increase the amount of capacity the systems can do today. You know what we're going to do? This is not stuff that is just slideware. We have a chip looking just like that, which does all of this today. And we're going to demo it to you, to prove it to you that it's possible. And in fact, if you want to try it, we're going to give you a way to try it today. You can come in and try it for yourself. What you're going to do in this set of videos is going to talk about all of these features and end it up with a beautiful demo that shows you what exactly this thing can do. So we talked about software in silicon, but what is software in silicon, right? What it is. Basically, physics is physics, right? So you have to follow the laws of physics. So how all of this works is that we have a chip, right? The chip has got a standard size. You can't do too much of it. So what did people do? They started putting smaller and smaller transistors, right? We're talking nanometers. We're talking like 28 nanometers, 40 nanometers, 20 nanometers, and so on, right? This means it allows us to put certain number of transistors into a given area. So what you do with this real estate is completely up to you. That's where chip design comes from. That's where all the smarts come from, right? So this is basic stuff. Back in the 90s, what people were doing was they had one directional thought. All they did was kept on increasing the clock rate. That's all they knew how to do. So they went on keeping on increasing clock rate. And what they found out was this thing is not the right thing to do. Sun back then came up with an idea and they said, hey, let's not just focus on clock rate. Let's do things in parallel. Let's break up this chip into smaller chunks that would do parallel things, right? That was the first idea of what we used to call as chip multithreading or multi-core chips, right? That's a very simple idea. And now what happens? The whole industry is doing it, right? We are seeing competition doing the same thing. They're just adding more and more cores to the chip. What does Oracle do? Think differently. Think outside the box. What's the point of a microprocessor? The microprocessor does one thing, run software. The microprocessor in itself, if it doesn't run software, it's just really good for one other thing, frying eggs, right? We don't want that. We want it to run software. So what did we do? We pushed software into the silicon. What does that mean? This software that we have, we work in a company that makes 650, 700 different software. This allows us to look upstream and say, what does software actually run in silicon? Can I take some of these common functionalities that I'm seeing software do? Can I put it into the silicon? Guess what? It's very easy to do it. So what we found out was that using a very little chip real estate, very, very little chip real estate, we can bring in some common software functionalities into the chip. So what did we do? We looked at the database. What are the problems that the database is trying to solve? It is doing linear searches. So can I put some stuff to do linear searches in the chip? Of course I can. That's what we call as the performance feature, or we're going to talk about it called DAX. The next video, we're going to go into the details of what these performance features are. Then what we said, we looked at it. What's happening today is everybody is scared about security problems, right? We are seeing people breaking in. We are seeing people kind of, break into systems. And we are relying completely on human beings to be careful with the software they write. And what happens in reality is human beings are human beings, right? So they write buggy code. What happens in that case? Doesn't matter if your whole system is secure, you need a small little hole for the hacker to come in and break into everything. So what we wanted to do, we wanted to say, hey, can I put a covering around the human element and make sure that this is completely secure? Can we do that in chip? Of course we can. So what we did was we put a feature called ADI, Application Data Integrity. This allows us to basically put something in the chip that allows you to have a higher level of security than you would have, and not just rely on the fact that all your developers are writing code without drinking coffee, right? We want to make sure that as developers, even if they make mistakes, we want to give a coverage here. What's the third thing we saw? Immense capacity. We have systems today that can have 32 terabytes of RAM, but that's not enough. Data is exploding. What we really want to do is the ability to actually have access to more data. We would like to do compression. We'd like to put compression on disk. We'd like to put compression in memory. We'd like to compress the amount of data that needs to be transferred from memory to chip. So what did we do? We did decompress on chip. So what this allows you to do is let data be compressed in memory, and then we move compressed data, which means the bandwidth to memory is reduced, and then we can do all of the work on compressed data here on the chip because we decided to put decompress on chip. So that's the third feature. What we're going to do in the rest of the videos is we're going to go into each one of these, and we're going to talk about details of how we do security, how we do DAX, how we do database acceleration, how we do performance, and how we do extra capacity using software and silicon on chip. Hope you guys stick around to watch the next set of videos. Guys, you heard about all of the features that we have in silicon in the M7 chip. You can register to try out the software and silicon cloud today. All you have to do is to go to the swissdev.oracle.com website and register to access an M7 chip today. And you're going to be able to try out these features that we are talking about in these videos.